Assalamu alaikum, my dear fellows and students. I hope you will be fit, fat, safe, and sound. Once again, I am going to share my knowledge according to the fixed point theory and a Banach contraction principle, which play a keystone role in fixed point theory. Let's see from the screen. It is the definition of a geometric space. You can see from the screen along with 5 properties. The second one is the Banach contraction. Here we have to use in a geometric space. You can see from this definition and from the screen. Clear? And the third one is the theorem. Here we have to use the Banach contraction in the given theorem. You can see from the screen. Let's see its proof. Its proof consists of the 4 steps. The first one is the addition of a sequence. Like in this manner, I am going to describe the terms of a sequence. You can see from the screen. It is a Picard iteration sequence. The second one is applying the contraction mapping, whether the given contraction is Banach contraction, or Karan type contraction, or Chatterjee type contraction, or Hardy-Roger type contraction, or your made contraction, which fulfill the terms and sequences of the fixed point theory. Here first we apply its initial term of the sequence x1 and x2 pay, or after applying the contraction, Banach contraction, we get c times c times g of x0, x1 and x1, or secondly its terms x2 and x3, and we get the like terms like first term. Put like this, put this value we can get here after applying the contraction. With same mechanism we proceed next terms and up to so on, up to n term of make it mapping form, and that apply the Banach contraction for 1 times per second time, and put their previous values. We get its terms of the sequences after applying the contraction, which shrinks to the x0, x1 and x1. Yes, and after this, the third step, to make the iterative sequence to be a Cauchy sequence, make like this mechanism for the terms of a sequences like this. M is strictly greater than n is the 2 terms of sequences, and write these terms of sequences in summation form. You can see from the screen like this. Take common point series to power n from the given constants. We get the infinite geometric series like this. You can see from the screen. When n approaches to infinity, or nothing, any element not equal to 0 raised to power infinity, we get the value of 0, which gives us a xn is a Cauchy sequence. Clear? The fourth one is the fixed point. Since x is a complete, xn converges to say x, any element say x, applying same mechanism, g of x, ftx and tx make triangular equality. The colored part shows the triangular equality. Applying the contraction like this, when n approaches to infinity, we give a fixed point t of x is equal to x. You can see from the screen. The last one is the uniqueness. If possible, let y not equal to x be another element. Now check its mechanism, g of x y y and g of t x t y, and get after applying the contraction, we get which is clear than which is a contradiction. This contradiction leads to us, so x is equal to y, so its point is the unique. For more videos, like and comment positively, inshallah. Thanks.